Hi everyone, and thanks for joining. Today I'm going to walk you through this room, Python for Pentesters, available as a part of scripting for Pentesters module on TryHackMe, where you can learn to use PowerShell and Python in different stages of a penetration test and take your pen testing craft to the next level. So let's now switch to the room itself. Python is probably the most widely used and most convenient scripting language in cybersecurity. This room covers real examples of Python scripts, including hash cracking, key logging, enumeration, and scanning. This room itself has 10 tasks. I'll read through each of these, then proceed going through each task hands-on. So first I'll start the target machine. And a tag box, as you know, we'll need it. So while the machine is initializing, I'll read through task 1, Introduction. Python can be the most powerful tool in your arsenal, as it can be used to build almost any of the other penetration testing tools. The scope of this module does not allow us to go into too many details on Python. Still, we will cover several key areas that will be useful during engagements and help you better understand Python. Please complete the Python basics room before proceeding, as this room will not go over the basic usage and programming features of the Python language. We are not learning to become a developer. Our objective is to become a penetration tester. This room will give you pointers on which you can build and improve. Examples are given on one of each basis, and no code should be considered as the only and correct way to reach a solution. Our goal is then to build quick and effective tools that will help us in our daily tasks. Throughout this room, you will see how to use Python to enumerate the target's subdomain, build a simple keylogger, scan the network to find target systems, scan any target to find the open ports, download files from the internet, and crack hashes. Any code you will find in this section can be compiled using simple tools such as PyInstaller and sent to the target system. Notice a word list that will be useful to complete tasks related to the target system associated with this room can be found attached to the next task. The word list was also added to the attack box and is located in the following path. User share word lists Python for Pentesters word list 2 txt. To access the machine you start on this task, you need to either use OpenVPN. Go to the access page and connect to our network via OpenVPN. This is important to do before you can access the machine. Or use a tag box, recommended, and we will do just that. Start the tag box, blue button at the top of the page, and write your Python scripts through the browser. Answer the questions below. What other tool can be used to convert Python scripts to Windows executables? So let's see the hint. External research may be required to Google, Bing, etc. And with that we can come to this answer. So I'll focus on the hands-on part. And second one, start the machine on this task. No questions here. Let's proceed to task 2, subdomain enumeration. Python gives us an easy way to automate tasks during a penetration test. Any tasks that you have to perform regularly are worth automating. While the automation process comes with a learning curve, the mid and long-term gains are worth it. Finding subdomains used by the target organization is an effective way to increase the attack surface and discover more vulnerabilities. The script will use a list of potential subdomains and prepends them to the domain name provided via a command line argument. The script then tries to connect to the subdomains and assumes the ones that accept the connection exist. As you can see, the script above will search for a file named subdomains.txt. The simplest way is to use a word list located in the same directory as the Python script, but any word list can be used. The word list should have possible subdomains listed one per line as shown below. You don't need to download the word list attached to this task if you're using the attack box, as it can be found under User Share Word Lists, Python for Pentesters, Word List to TXT. Let's try to answer the questions below. What other protocol could be used for subdomain enumeration? Let's see the hint. How does the browser find the IP address of any domain subdomain? And the second question, what function does Python use to get the input from the command line? And let's see the hint. Never get into an argument with the system unless it's this one. So let's see the code above. To answer this question, we'll need the code. And that would be sysargv. So that would be it for this task. We are not provided with any domains here to test this code with. Let's proceed for now. We'll get back to this task if needed. Task 3, directory enumeration. As it is often pointed out, reconnaissance is one of the most critical steps to the success of a penetration testing engagement. Once subdomains have been discovered, the next step would be to find directories. The following code will build a simple directory enumeration tool. At first glance, you will certainly notice the similarities with the subdomain enumeration script. This script takes an approach based on a for loop and passes all 404 responses. Make sure you have downloaded the word list file from task 2 before proceeding with the following questions. The word list was also added to the attack box and is located in the following path: user share word lists, Python for Pentesters, word list to txt. And we have questions. How many directories can your script identify on the target system? Extensions are .html, so we'll need this code for that. Also, we'll scan the target system to find the answer to this question. So next question will be, what is the location of the login page? Next, we'll have to find the answer to where did you find a cryptic hash? Where are the usernames located? And what is the password assigned to Rabbit? So let's proceed to the hands-on part. Let's first show split screen and then view in full screen. Or let's see, maybe we won't need full screen for now. Let's try like this. So we'll use this code and let's name it dir_enum.py. Let's put it on desktop. Okay. Then let's copy paste this word list on to desktop. Clipboard error. I don't think I messed anything up with this. So let's proceed with copy pasting word lists to desktop. And let's adjust the Python code because at the moment it uses word list.txt. We need to rename it to word list 2. And let's proceed to scan our target. And here is the target IP address. So it's Python 3 and target IP address. And here's the answer for first question. How many directories can your script identify on the target system? Okay, and let's proceed to open each of these pages to see what we have there. This is because we have it open as in a full screen window. Maybe it would be easier to proceed like so. Let's try with that. Then next page. So this one ends with server. Next one is private. Third one Apollo. And the fourth one index. Okay, and with that, let's see what is the location of the login page. Okay, we see it here. Then where did you find the cryptic hash? That would be this one. Where are the usernames located? So those would be these users. And what is the password assigned to Rabbit? We can see that here. Okay, let's proceed to task 4, network scanner. And let's close out this split view. Python can be used to build a simple ICMP, Internet Control Message Protocol, scanner to identify potential targets on the network. However, ICMP packets can be monitored or blocked, as the target organization would not expect a regular user to ping a server. On the other hand, systems can be configured to not respond to ICMP requests. These are the main reasons why using the ARP, Address Resolution Protocol, to identify targets on the local network is more effective. This is the code. And if you're using the attack box, you will need to install Scapy first. This can easily be done using the apt install python 3 attack Scapy command. And we'll run the code with python 3, then the codes, and adjust what needs to be adjusted. The questions are: what module was used to create the ARP request packets? So we see it here. Which variable would you need to change according to your local IP block? That would be this one. And what variable would you change to run this code on a system with the network interface named ENS33? So that would be this one over here. And let's proceed to scan the network where the target machine is. And let's see how many answers will we get back. Something similar as shown on this screenshot. So we'll check our attack box IP address, match the interface with this target IP CIDR range. And we then expect to see the target machine's IP address back with its associated MAC address. So let's try with that. As is first. We'll call this code arpscan.py. Let's create the Python. Let's create a file, arpscan.py. And let's save it for starters. And let's check our IP address. We are currently on the tech box. Let's run IPA. So we'll need to match IP range of the target. That would be 10.10.186.0/24 if possible, and let's check the interface for that range. So we see here the closest one from these available here would be ENS5 with this range 10.10. So our IP address is TechBox IP address is 10.10.254.22 in the /16 IP address block. Though we'll proceed, so the code will adjust it. Let's try to target. So /16 would give us over 65,000 IP addresses, if I'm not wrong at my math right now, to scan. So that would be too much. Let's try to adjust the code to scan this IP block with /24 and use ENS5 as interface. So let's try with that. So that's ENS5. 254 is the third octet. And let's install Scapy. So for these, to answer these questions, we do not need to test out this code, but let's do it. Let's do it because we have available all the information. So when we use this code in the IP range that covers the target IP address, we expect it to get back in our answers that IP with associated MAC address. So let's see what we'll get. I already went through this room and couldn't get this code to work as expected. So I'll try again now and proceed to an alternative I found. First, this code outputs a couple of errors, but continues to run. So we'll wait until it completes. So we'll for now ignore these errors. It stated that there is one answer ending an IP ending with 18, and that's not our target IP, target machine's IP address. So this code currently doesn't look it's working as expected. So an alternative for this I found is first let's verify with net discover. Let's see if it's already installed. Let's install it. So let's first see what net discover will show us, and then proceed to another Python code for ARP scanning. So net discover will need the range and need device, which is network interface. And before that, let's adjust the code to try two more things before we proceed to net discover and alternative Python code for ARP scanning. So let's edit first the code. Let's try here to put as the last octet in this IP range 1. Let's see if that will impact the results anyhow. And we have again one answer. IP octet ends with 18. The same answer. Okay, and let's adjust the code last time with an exact IP address of the target machine. And that's .40. 180. Okay, we'll scan the IP range covered by our DEC box's ENS5 interface, and within IP range within which we can find the target machine 10.10.186.0. So let's try with that. So first code outputs a couple of errors, but continues working. So we'll ignore these errors for now. And we have 0 answers back. Let's try to adjust the code with IP range, with the last octet of the IP range to be 1. Let's see if it will see target machine's IP address that way, because we know it's on, and we should see it in output. So at the moment we are targeting the whole /24 range of IP addresses, and no, still no answers. Let's adjust the code to target only target machine's IP address. So that's with the last octet 40. And it says we have one answer. It shows it got us back target IP's address, and it recognized its MAC address. So if we target only one IP address, we can get the answer back. But let's try with Net Discover to see what it will output. We'll add the interface ANS5, and let's scan the /24 block of IP addresses. And 86. Let's put .0/24, and that's the range. Let's put TechR here, and let's see if Net Discover will immediately recognize our target machine's IP address and MAC address. Let's give it a minute. So Net Discover recognized a lot more up and running hosts and their MAC addresses, and among them we see our target machine's IP address and MAC address. So let's stop it now. And so Net Discover rewrote our ARP scan Python code, so let's rerun it to compare MAC address here and here. Okay, yeah, that's a match. So Net Discover recognized a lot more hosts. And one other alternative for ARP scanning with Python I found on GitHub is from Dharmil Chadva. He explained how the code works in his blog or here, and we can find the code in his GitHub. So that's this network scanner. We'll download the code and provide it with target IP range. So the target IP range, we'll put the last octet 1 and then /24 and compare it with Net Discover and the first Python code for our scanning we used. We'll call this ARP scan 2. Let's run a quick visual check. And let's keep everything as is. And let's adjust this command. So we'll use the target range 10, 10, 186. And we set last octet to 1. And we called our code arpscan. Okay, looks good for now. Let's try that out. It also outputs similar mistakes as the code from try-hack-me-run. So let's send the errors to DevNull. And this is what the code output. We can compare with the net discover output and conclude it's not a 1-1 match, but this will be sufficient for this room. And let's proceed to the next task. So that would be one way to build your own ARP scanner using Python. Task 5, port scanner. In this task, we'll be looking at a script to build a simple port scanner. This is the code. And to better understand the port scanning process, we can break down the code into several sections. Importing modules that will help the code run. Import sys, import socket. Modules could also be imported with a single line using import socket sys, specifying the target IP. We'll adjust the IP to match our target machine's IP. An empty open ports array that will be populated later with the detected open ports. Ports that will be probed. And for this example, we have chosen to scan all TCP ports using the range function. However, if you're looking for a specific service or want to save time by scanning a few common ports, the code could be changed as follows. Provide specific ports of interest. The list above is relatively small. As we are trying to keep a rather low profile, we have limited the list to ports that will likely be used by systems connected to a corporate network, getting the IP address of the domain name given as target. The code also works if the user directly provides the IP address. Tries to connect to the port. This code is followed by a for loop that iterates through the specified port list. And below are the results of the port scanning script run against a random target. So we'll run the code, see this kind of ASCII art, and get the back open ports list. Of course, I will be the first one to admit the ASCII art banner was a bit much. Their banner will require PyFiglet to be imported. If you are using the tag box, you can easily install PyFiglet using the apt install python 3 tag pyfiglet command. If you wish to remove the banner, you can simply delete the following lines for ASCII banner and printing the ASCII banner. In this task, we have a couple of questions to answer. First question, what protocol will most likely be using TCP port 22? So based on our previous knowledge, we should conclude that that's SSH. What module did we import to be able to use sockets? So looking at the code, that would be socket. What function is likely to fail if we didn't import sys? So let's see what function uses this. It's this one. How many ports are open on the target machine? So we'll have to run the code to get that answer. And what is the highest port number open on the target system? Also, we'll see that from the code output. So let's proceed to the hands-on part. Copy paste the code and adjust it. Let's adjust the IP address. Everything else will keep as is. Also, let's install PyFiglet. Let's call the code port scan. So we'll use our target machine's IP address. Check target IP address, yep, and install PyFiglet. And let's run the code. Great, we have our answer back. So we have 3 open ports. And the answer to the last question. It's a match. Okay, let's proceed to the task 6 file downloader. wget on Linux systems or certutil on Windows are useful tools to download files. Python can also be used for the same purpose. The code and this short piece of code can easily be adapted to retrieve any other type of file as seen below. psexec allows system administrators to run commands on remote Windows systems. We see that psexec is also used in cyber attacks, as it is usually not detected by antivirus software. You can learn more about psexec here and read this blog post about its use by attackers. So 2 questions here. What is the function used to connect to the target website? And we can see it here in code. And what step of the unified cyber kill chain can psexec be used in? So we can find that answer in provided blog post. And let's proceed to task 7, hash cracker. A hash is often used to safeguard passwords and other important data. As a penetration tester, you may need to find a clear text value for several different hashes. The hash library in Python allows you to build hash crackers according to your requirements quickly. HashLib is a powerful module that supports a wide range of algorithms. Leaving aside some of the more exotic ones you will see in the list above, HashLib will support most of the commonly used hashing algorithms. Hashcracker, and this script will require 2 inputs, the location of the word list and the hash value. As you probably know, hash values cannot be cracked as they do not contain the clear text value. Unlike encrypted values that can be reversed, e.g. decrypted, clear text values for hashes can only be found starting with the list of potential clear text values. A simplified process can be seen below. You retrieve the hash value, so this one for example, from a database, which you suspect is the hash for a number between 1 and 5. You create a file with possible clear text values, numbers from 1 to 5. You generate a list of hashes for values in the clear text list. Hash values for numbers between 1 and 5. You compare the generated hash with the hash value at hand. Matches hash value of the number 3. Obviously, a more effective process can be designed, but the main principle will remain identical. The script below follows an approach close to the one described above. First asks for the location of a word list, then asks for the hash to be cracked, then reads values from the word list, 1 per line, then converts clear text values to MD5 hash values and compares the generated MD5 hash value with the value entered by the user. Below, the MD5 cracking script, including the absolutely optional and tacky ASCII art banner. And we have a couple of questions here to answer. First one, what is the hash you found during directory enumeration? So we can see that here, that would be this one. What is the clear text value of this hash? So we'll use this code provided here to get that answer. Then we'll modify the script to work with SHA-256 hashes. We see from the code it currently uses MD5 algorithm. and using the modified script, find the clear text value for this specific hash. So let's proceed to do just that. Let's copy paste this code and name it hash.py. Let's close this out. Let's keep everything as is, also the banner. Okay. So we have to find the clear text value of the hash, and we'll use our word list tool from desktop, provide it the hash, and we expect it to find the clear text password. Okay, let's run it. Enter word list file location, so it should be on desktop. Let's verify that. Okay, there it is. So that would be root desktop word list to txt. Has to be correct is the one we found here, and it found the clear text password from the word list. So let's check out how many lines the word list contains, because this was pretty quick. 437. Okay. The next question would be, okay, let's modify the script to work with SHA-256 hashes, and let's give it this hash to see if it will crack it. So for SHA-256, let's replace here MD5 with SHA-256, and let's rerun the code. Let's use the correct hash, not this one. Let's rerun the code. That's the one. And it found the clear text password. be the answer to the last question in this task. Let's proceed to task 8, keyloggers. Modules allow us to solve relatively difficult problems in a simple way. A good example is the keyboard module, which allows us to interact with the keyboard. If the keyboard module is not available on your system, we can use pip3 to install it. pip3 install keyboard. Using the keyboard module, the following 3 lines of code would be enough to record and replay keys pressed. Keyboard record will record the keys until enter is pressed, and keyboard play will replay them. As this script is logging keystrokes, any edit using backspace will also be seen. Answer the questions below. What package installer was used? That would be pip3. And what line in this code would you change to stop the result from being printed on the screen? So that would be this one. So to demo a Python keylogger, I couldn't get this piece of code here to work as author intended, but I found an alternative available in Satyam Patania, sorry if I butchered your name, GitHub, and I'll proceed to demo this code available in his GitHub. So the code relies on PinePut project, and I'll install that also. So let's start first with copy pasting the code from GitHub. So his code, as he explained in his GitHub, creates a text file and the keystrokes will be logged in that txt file. So the thing with this Python code is that it relies on PinePut, and when I first and the first time I went through this room, I encountered several errors related to this PinePut project. I found this useful open issue that mentions a note uv add pineput equals 178 fixes the issue. So uv then is an extremely fast Python package and project manager written in Rust. So to get this to work, we'll install pineput and uv and then run the Satyam's code. So let's proceed like that. Stick with clipboard and copy pasting. So this open issue also mentions Python 3.11. So we'll install that with uv. So we'll first check if it's available already on the tech box. It's not, but it can be installed, and we'll install it. This command is shown here. Let's include this switch classic. And looking at UV instructions, so it's a single tool to replace pip, pip tools, pipx, poetry, pyenv, twine, virtual env, and more. And I'll run a couple of commands from the instruction to get the code up and running. It will create a couple of files on its own. And let's install UV Python measured version 3.11. So that's the way I got it to work as of today, 10th of March 2025. And then let's run the code. So for that we'll just run UV run and name of the Python code. UV run and the name of the Python code, keylogger. We expect to see one txt new file, one new txt file where the keystrokes will be logged as explained in Satyam's GitHub. Keylog.txt. So let's open a new terminal tab and start typing over there something. Please, there it is. We have something. Please subscribe. Channel. THM is the best 2025. Okay, and let's stop the Python code now and see if we have this content now available in the keylog.txt file. There it is. Please, then key space, subscribe. Yeah, we would truncate this part if needed to my YouTube channel. Try Hack Me is the best 2025. Great. So that's all for this task. And let's proceed to task 9, SSH brute forcing. The powerful Python language is supported by a number of modules that easily extend its capabilities. Paramico is an SSH v2 implementation that will be useful in building SSH clients and servers. The example below shows one way to build an SSH password brute force attack script. As is often the case in programming, there rarely is a single correct answer for these kinds of applications. As a penetration tester, your usage of programming languages will be different for developers. While they may care about best practices and code hygiene, your goal will more often be to end with a code that works as you want it to. By now, you should be familiar with the try and except syntax. This script has one new feature, def. Def allows us to create custom functions as seen below. The SSH connect function is not native to Python, but built using Paramico and the Paramico SSH client function. Reading the code, you will notice several distinct components. Imports. We import modules we will use inside the script. As discussed earlier, we will need Paramico to interact with the SSH server on the target system. Sys and OS will provide us with the basic functionalities needed to read a file from the operating system, our password list in this case. As we are using Paramico to communicate with the SSH server, we do not need to import socket. Inputs. This block will request input from the user. An alternative way to do this would be to accept the user input directly from the command line as an argument using sysargv. SSH connection. This section will create the SSH connect function. Successful authentication will return a code 0. A failed authentication will return a code 1. Password list. We then open the password file supplied earlier by the user and take each line as a password to be tried. Responses. The script tries to connect to the SSH server and decides on an output based on the response code. Please note the response code here is the one generated by Paramico and not an HTTP response code. The script exists once it has found a valid password. As you will see, the script runs slower than we would expect. To improve speed, you may want to look into threading this process. Make sure you have downloaded the word list file from task 2 before proceeding with the following questions. The word list was also added to the tag box and is located in the following path: user share word lists, Python for Pentesters, word list to txt. And we have 3 questions to answer. What username started with the letter T did you find earlier? So we can find that here. Then what is the SSH password of this user? So we'll use the provided code for that. And the last question, what is the content of the txt file? So let's see how to get that answer based on previous ones. Okay, now let's copy paste this code. Let's not forget to use the clipboard. call the code sshbrute.pub. Let's paste it. Let's run a quick visual check. Okay, the moment looks good. Now let's run the code, Python 3. We could pipe this error to dev-null, but let's keep it like this for now. It did not, this error did not break the code execution. We have this question, please enter target IP address. So that would be our target machine's IP address, 10.10.186.40. Username to brute force. That would be this one. And a location of the password file, that's our word list 2. So it's checking. Let's give it a minute to see if it will find password from the supplied word list 2. And we have a hit. So let's try to SSH to the target machine with Tiffany's credentials. So we are doing that to get the content of the txt, of the flag.txt file. We just found the password. And with that, let's see if we can find the flag.txt file in Tiffany's home directory. There it is, and we could get it out. And the answer to our last question will be in that flag.txt file. And let's proceed to the last task for this room, extra challenges. Based on what we have covered in this room, there are a few suggestions about how you could expand these tools or start building your own using Python. For example, use DNS requests to enumerate potential subdomains, build the keylogger to send the capture keystrokes to a server you built using Python, grab the banner of services running on open ports, crawl the target website to download JS library files included, try to build a Windows executable for each and see if they work as standalone applications on a Windows target, and lastly implement threading in enumeration and brute forcing scripts to make them run faster. There are no questions in this task, so that would be all for this video. Like and subscribe if you enjoyed this one. Until next video, bye for now.